Hey, sixth graders, welcome back to my dining room. Here to talk to you about one more thing today, a thing called the mean absolute deviation. It sounds really scary and intense because the words are big and scary, but they're really quite simple. Um, this is when we talk about how different is the data within a set. So what we've got here essentially is a dot plot. I'm going to do a little quick hands-on thing here. While I'm doing that, kind of talk you through what it is, and then I'll give you a little example to try on your own. It's not that big of a deal once you understand what we're talking about. So when we talk about mean absolute deviation, it talks about just about how far away is everything from the mean or the average of the data. And that's what we're going to think about. We start with the average. The last lesson we did was all about the median. This one's all about the mean, the average, this kind of mean, not just, yeah. So absolute means either positive or negative. It can be either larger or smaller than the mean. And deviation really means how different or how far away is it? How far is it deviating from the average in this case? So what they did was they gave us a quick little example. It says the stat plot shows the ages of gymnasts registered for their school team. The mean age is 10. That's important information. I need to know that. So knowing that, the mean age is 10. That's my starting point. Once I know what the mean is, I need to see how far away all the other data points are from that value. So what I'm going to do is I'm going to kind of mark this. If I know that my mean is 10, I'm trying to figure out how far away everything on either side of this is from that spot. So what I'm going to do is I'm actually going to look at every single dot. I look at these dots stacked up at 10. How far away are they from 10? Well, 0. These are worth nothing. This one here, if I go to the left, 9 is the data value of that dot. It is 1 away. Yes, it is -1, but it's still just 1 away. We're thinking about absolute value here. These guys are all 2 away. 2, 2, 2, 2. They're at 8. The mean is 10. Those are all 2 away. We have to count every last one of them. We can't just pick one and say it's a 2. We have to count them all. I'm going to go in the other direction now. There's 0 data points at 11. 12, there's 3 12-year-olds, and how far away is 10 from 12? 1, 2. So I'm going to mark these all as 2s. You'll see what we're going to do here in a minute. And then there's one 13-year-old who's still on the team, and that person is 3 years older than the mean. So I'm going to mark that as a 3. So now what we're going to have to do here is we're going to have to take all of these data points, every one of them, add them together, and what do we get? We get something that looks like this. Okay, so now what we're doing here is we have all of our numbers, all of our 2s that are away, plus our 1, all the 0s, the 2s. We take every data point, we add them together, and we divide them, just like finding the mean any other time. We divide them by the number of data points we have. So if we add them all together, we get a total of 18, and we even count the 0s. Divide it by 12, and our answer comes out to be 1.5 years. What is that even saying to us? And that's the real question. What does it even mean? What it means is that all of the data points, in this case, all of the kids, their ages are all within a 1.5 year range of the mean. That is the absolute average or mean deviation. It's something that's used to kind of figure out how to group people together, how to group information together. I'm going to do one more quick example on the other page, because sometimes you can look at this a slightly different way. This one way you can do is with a dot plot, and there's one other quick way that we can do this. I'm going to show you. Sometimes you just have a very simple data set. We're just going to focus on this one right here. Sometimes you have a very simple data set, and it says the number of laps that Lara swam on 5 different days. Okay, basic stuff. So here they are. They've given us the mean. We know what the average is. Now, what I can do is figure out, looking at every one of these data points, how far away are they from 7? So if I know everything is being compared to 7, I look at my first data point, 1. How far away is 1 from 7? I'm going to make a little table here. How far is 1 from 7? It's 6 units away. How far is 3 from 7? It is 4 units away. How far is 7 from 7? 0. 11, going in the other direction, is 4. Oops. This is why we use pencil. It's math class. 11 is 4 away, and then our last number is 13, and that one is 6 away. So now I can take all of these. This is kind of the same thing we did before, and add these all together. 6 plus 4 is 10, plus 0 is 10, plus 4 plus 6 is a total of 20 laps. And we're going to divide it by the number of days. 1, 2, 3, 4, 5 days. 20 divided by 5 is equal to 4. Our mean absolute deviation is 4 laps. So there's a little bit of math to go here, but it's kind of one of these processes that if you just take it step by step, and I'm going to leave a little cheat sheet for you attached to this assignment. If you take it step by step, you should be able to get through this pretty quickly. Go ahead and try to show your work right there on the slides when you're doing this, and please let me know if you have any questions.